Hey there, and welcome to the channel. This is my very first go at making a video, so I'm keeping things simple and testing how quickly I can put a video together. The plan? To share cool science and math concepts as soon as I stumble upon them. No over-the-top production, just straightforward and quality content. No flashy effects. For this first video, I'm kicking off with something simple yet powerful: how to use symmetry to evaluate integrals. Let's dive in. So I came across this meme the other day and it instantly grabbed my attention. Just look at that integral. It seems absurdly complicated at first glance, right? Like, where do you even start? But here's the thing. With a bit of practice and an understanding of symmetry, it's actually pretty straightforward, something you can solve in your head with confidence. Let me show you how it works. All right, let's take a closer look at this integral and break it down step by step. The first thing to notice is that the limits of integration go from -2 to 2. That means the interval is symmetric about 0. A really important clue when it comes to simplifying integrals. Next, let's analyze the pieces of the integrand. This part here is an even function. It's symmetric about the y-axis, and this part here, that's an odd function. It flips sign when you flip x. Here's the cool part. Whenever you integrate an odd function over an interval that's symmetric around 0, the result is always 0. Indeed, the part on each side of 0 will exactly cancel out. That's great news for us because it makes solving this integral way easier. Let me show you how. So, let's break our integral into two parts to make things clearer. The first part involves the integral of an odd function. Why? Because the integrand here is the product of an odd function and an even function, which always results in an odd function. And here's the fantastic part. We already know that the integral of an odd function over a symmetric interval, like this one, is exactly 0. No work needed. That leaves us with only the second part to focus on. Take a moment to really look at it. Does it feel like something you can solve without doing any heavy computation? Let's see if you can crack it before we move on. That's right. The integral is simply the area of a half circle with a radius of 2. No tricky calculations, no messy algebra, just a quick observation and boom, we're done. The answer? 2 times pi. No computations, no hassle, just pure symmetry and a bit of clever thinking. How satisfying is that? So in the end, cracking that integral wasn't so bad and you get free Wi-Fi. So how long would it have taken you to get that free Wi-Fi? Let me know. And yes, that's the only decimals of pi I remember. 9 decimals is not all that bad. All right, I'm going to wrap it up here. I had planned to dive into a few more things, like the integral you see on screen and some other cool tricks, but wow, creating this first video took way longer than I expected. Looks like I've got some work to do to speed up my video making skills. Let me finish by mentioning this fantastic book for anyone who's into sneaky integrals. It's packed with all the cool stuff: Feynman tricks, clever substitutions, elliptic integrals, contour integrals, you name it. If integrals are your thing, this book is a goldmine. You can find a link in the descriptions. Today's example was super basic, really just an excuse for me to test how long it takes to make a video. But hopefully, I'll get to dive into some of that advanced stuff soon. Thanks for watching, and see you next time.